The nature of the Cornerstone modules laid the foundations for a style of teaching that we were trying to encourage and promote for a very long time. Reduce teacher talk and maximise pupil-led lessons. So if a teacher tried to lead the lesson from the front using a Cornerstone module, the pupil will become very disengaged because the materials are actually designed for the pupils to interact and engage with. Both the Cornerstone units flip around the dynamics of your lesson. It is the pupils who make the discoveries. It is they who make the observations, and they too who are asking the questions. The teacher merely becomes a facilitator. The teacher's role changes and evolves as the mathematical ideas develop. And when posed by a question from a pupil, it is answered with another question, and the teacher needs to try their best not to answer the question for them. The pupil then begins to make links between the concepts taught, and hence this helps develop their higher order thinking skills. And I'll give you an example. I had a pupil that asked, what happens when the scale factor is between 0 and 1? And rather than answering the question, you would respond to this with a question. Well, what do you know happens when the scale factor is 1? And then follow it with another question. What happens when the scale factor is 2? And what happens when you have the number 2 and you multiply it by a half? And in answering these questions themselves, they are able to answer their own original question. This technique helps develop the pupil's thinking. Sometimes there are limitations. Pupils will have to share computers, so the teacher is automatically posed with a challenge. Are all the pupils going to be given the same opportunities to interact with the resource? Are they going to have the same experience? Are they going to have the same chance? Or are you going to have one student taking over the computer altogether? So again, it becomes a teacher's role here to ensure fair participation, but more importantly, to promote collaboration and discussion between the partners. You would go around and ask them questions that the partners then start to discuss. And the issue isn't that they're sharing the computer, the issue is that they are sharing the concept and ideas. And ultimately, their experience on this single task is enriched, and they challenge each other in their thinking through their discussions. And again, this develops their mathematical abilities. Our pupils, in particular at Stratford School, benefited from the opportunities of whole class discussion. It was a learning curve for the teacher to see how our multilingual pupils develop their skills of mathematical reasoning and explanation. It was also an opportunity for the pupils and the teacher to model the correct use of mathematical language. We found that because our pupils were constantly collaborating and debating, not only in their own groups, but as a whole class, their mathematical thinking was strengthened. And this was evidenced through end-of-unit test, where we gave Year 8 pupils a GCSE question on speed time graphs, and they answered it better than current GCSE pupils. Thank you.